So you bought yourself a project car. What do you do now? Maybe you bought the car knowing it was a project. Maybe you bought it, got it home, and realized it was going to be a project. There are a few simple things I suggest you do with any old car that you get, whether you're just verifying the condition or fixing maybe some basic problems that most of these usually have. This is my 1957 Continental Mark II, and I bought this car knowing it had been sitting quite a long time. So I knew there were some pretty normal things I was going to have to do. Now, compared to some of the other crap I've had, this actually came as a pretty nice car when I got it. But still, the master cylinder was completely corroded. You could just see in the pictures, actually when I bought it, that this thing was junk. And this actually has a fairly special sort of brake booster master cylinder set up in it, so this all had to be changed. It was beyond repair, and unfortunately on something like this, fairly expensive. So I knew that before I bought it, that this was going to be an investment. But I bring up brakes because that master cylinder seal often can go. Also, look at this. This isn't very normal, but it has a rubber hose coming right out of the master going to the junction block. Change all of these. All of them. Normally you would only have one at the front wheels, one at the rear axle. For rubber hose, I have another one right here. So change immediately. These, and honestly, the wheel cylinders, I would change too. So now this car has a new master cylinder, all new rubber hoses all throughout, all new wheel cylinders. I trust the brakes in this thing, and that's number one. Don't go until you know you can stop. So after brakes, the next thing I would recommend looking at is fuel. I've already changed the fuel pump. Those diaphragms can go bad, and also all the fuel lines. All the fuel lines have been changed to hoses that can accept E85. I'm never going to put E85 in this thing, but if they'll take E85, they'll take anything, all right? And that's any rubber in that fuel system you're going to want to change. I haven't even gotten to the carburetor yet. I don't think the secondaries are opening. That's another diaphragm, rubber diaphragm that needs to be changed. But you know what? Other than that, it runs pretty good. So I haven't gotten there yet. All right, brakes first, fuel second. Next, we need to go to electrical and ignition. All right, so you may be able to see that I already have a new battery. The only battery that fits in this car is a 32N frame to fit the bracket and everything. So I paid quite a bit of money to get a new replacement. This is a glass matte style battery, AGM, that looks like an original battery. Totally not necessary normally, but in order to hold it down, have a new battery, did all that. What is necessary is make sure your ignition works right. So let's zoom in on that. Might need better light. There we go. So if you see, I already have a Petronics ignition module in there. One thing you would normally do is you would set your points, measure your dwell, measure your coil resistance. I just changed the coil, put in a Petronics, and new cap, new rotor. Tested the vacuum advance, and it's like a whole new distributor. Right, you also don't want that battery leaving you somewhere. So the next thing we want to check is parasitic draw. You can check that just by taking a battery terminal off and hooking up your multimeter in amp mode in between that battery cable and the battery. The key's off, everything's off, there's no hood light on, that should be 0. Or very, very close to 0. Maybe the clock's pulling just a little bit. If you're seeing anything above, maybe 2-3 milliamps, that battery's gonna go dead. So we can do that easily with the multimeter. This car fortunately has a fuse box, and we're able to isolate which circuit is pulling that draw. All right, so now we know our brakes will stop us, our fuel lines aren't going to break, and really, honestly, if you're buying an old car like this, probably need to flush the whole fuel tank. If the fuel tank's cheap enough, just get a new one. My Galaxy, they're like $200. I would just throw the old one away, get a new one. This one, you're talking $8,000. So take that out, get it flushed, make sure that you aren't going to be throwing junk into your carburetor, then it's time to start tuning. Right, some things you're going to need. Vacuum gauge. I don't know, 15 bucks, 18 bucks, something like that on Amazon. This tool is gold. Vacuum, every inch of vacuum you can get is invaluable. It just means your car is going to be running better if it's making more vacuum at idle. Next, if you do have points, if you haven't upgraded to a Pertronics yet, or you want to verify the Pertronics, a dwell meter. A lot of these are dwell tach meters, such as this one, which is also helpful when you're setting timing. Timing is dependent on the RPM. On this car, I should be checking the timing at about 550 RPM. If I'm checking it at 750, I'm checking it wrong. Also, a multimeter. Again, cheap, off Amazon. 15, 20 bucks at the most for a good one. Then, a timing light. Definitely need a timing light. This one is not a, what do you call it, rollback timing light, whatever. I can't adjust the degrees. This one is. Forgot this one was sitting here. This is my other one. This one has our dial back timing light. Now the problem is some of these are inaccurate. It shows a lot of these actually aren't that accurate, up over 1500 RPMs or so. But you can use them for a variety of things. Get timing at least close by adjusting that knob for what you want timing to be. I don't necessarily trust it though. I would trust more to make my own timing marks on the balancer after I've verified that the balancer is correct. And sometimes they're not. And I have my own videos on here. Search through my page. You'll see one about verifying your timing marks on your balancer. Another one about making your own timing tape to verify your timing marks. And then you can use a straight up timing light like this and not have to use one of these possibly suspect dial back lights. Okay, for testing the operation of Vacuum Advance, I have my vacuum pump hooked up to my Vacuum Advanced, and we're just looking to see if the rotor will turn. Or the base of the distributor. Yeah, looks like we are getting advanced there. How much we'd have to measure, which does look reasonable. The kind of range we're looking for. Okay, where does it start working? At 6, oh, about at 8 inches or so. Let's see if we can get back there. Creeping up on it. There we go. Right about 7.5 inches of vacuum. That thing starts to pull in. Now, as far as mechanical, we'll have to actually have the car running and check it against the balancer to see how it's working, but I am a little concerned. It's very loose right away. I imagine as soon as this thing starts up, it's going to be over here. And then we start to get some tension, but it goes from very loose to really tight tension. So I'm a little concerned about that. So hooking up my vacuum gauge, and it was a little chaotic to do so I didn't get it all recorded. I hooked my vacuum gauge up to the vacuum line going to the Advance to see how much vacuum it was getting at idle. Now I wasn't expecting full manifold vacuum because that looks like it's up above the throttle plate. But at idle, I had to make some adjustments here. Mine's off by about 4 inches. I can measure using my vacuum pump to see that. At idle, it's about 12 inches. So it is coming in. We have a little bit of vacuum advance influencing the advance curve at idle. And then right off of idle, it starts to come up. And I saw it was probably getting up around 2,000 RPM, nearly 20 inches. So we're definitely pulling in all that vacuum advance. That's what I'm looking for, better vacuum source. Now I'm getting what I'm supposed to be getting. Again, this is off by 4, so that's really showing 18 right there. And if I could show you, if I rev this thing up to about 1,000 RPM, there, it comes up to about 1920, just what we're looking for. Better vacuum source, better reading. So before you go blaming that carburetor for any of your problems, compression check's a good one to do, but definitely timing. Timing's probably the most important thing. And what a lot of people do is they don't know exactly their timing spec. Maybe it says 10 degrees. But when and how? On this car, you have to be at hot idle, which means about 550 RPM in gear, which means you need a friend. Don't trust that parking brake. Got another video about how I almost ruined a car that way. All right, so you want a friend in there once you've already done the brakes, making sure the brakes are good. And they're gonna pull that thing down into reverse. Why reverse? Well, it just says you need to time it in gear. If it's in reverse and something goes wrong, it's gonna go away from you. If it's in drive, it's gonna go over you. So put it in reverse. Get that timing set at that parameter. The advance is actually coming in before 550 RPM in this car. At about 350, it's already off those weights. So if you're not at the right RPM, you're not at the right timing. That was the case with this car. Okay, next I found, and I didn't really record this because it's really hard to record setting timing on an engine, but I unplugged the vacuum advance where I was testing with the gun, just that hose, and capped it. Here, let's see. Right down here, you might be able to see it. The vacuum hose going to the vacuum advance. Cap that, and then check the timing. And I have a dial back timing light. Since the marks are hard to see, I can only really see 0. That one's marked in yellow, which is a smart idea. It came that way. So it was at about 900 RPM, it was at 5 degrees when I had that cap. Now this is kind of common. What you can find is somebody will go and set the timing with the vacuum advance hooked up. And as I was saying before, that's adding like 12 degrees, quite a bit of extra timing with that vacuum hooked up. And that's not the idea. The idea is just to set the mechanical. So then again, with the vacuum capped, I revved it up to see what my total advance was, and it was only about 22 degrees. Also not very good. That's going to be really sluggish. So took, and so far I'm going to test this out since I know this is a pretty high compression motor with not a very efficient cylinder head. I would guess around 36 degrees, 34 degrees is what it's going to want. So I've increased it by about 7 degrees. So now I'm around where I'm supposed to be. The vacuum capped at idle, which is 550 RPM. This thing's finally getting that 5 degrees. Before it was actually like 0 or negative, a couple degrees. Once it was idling down that low. Down at that 550 RPM, finally at about that 5. I'm thinking it's gonna want more because now I'm only at, 29 degrees on the top end. It's gonna be a bit better than it was before, but I think it needs probably 3 to 5 degrees additional. But we're gonna go in steps. I mean, I'm not gonna make that big of a change and expect, golden results, but we'll see where we get. So always remember, when you're checking timing, get the vacuum advance out of the equation. Okay, how about the cooling system? Honestly, I wouldn't touch this unless there's a clear leak or something right away. If you get it running and it's running good, just don't get too far from your house. You don't want to test this by going on a 100-mile road trip. You want to stay nearby in case it does overheat. You can just shut it off, let it cool down a little bit, get back home. Easy test. It might be working fine. Few things. I knew this one when I opened the cap. That coolant was crusty. It had been sitting a long time. So flushed it all out, changed the thermostat. Thermostat gasket housing was leaking, so we changed that. Changed the water pump. Changed the cap. Now, normally this would have come with about an 8-pound cap. Put a 16-pound cap on there. Now, the only reason this should ever hit whatever that weight is if it's boiling. If it boils, it's going to go right to that pressure anyway. So I recommend going to a higher pound cap. It's not going to stress your system more. It's either going to be fine or it's going to boil and it's going to come out. That's it. So we've gone over some basic things. We've gone over some technical things. How about some more basics? Change the oil. if you can, make sure you drain all that coolant out, replace it, replace the fuel if you can. When you're working on the brakes, you're going to have all that open. Make sure you just bleed them good until that brake fluid is clean. Don't leave anything rusty, cruddy in there. And you're probably good to go. Notice I haven't blamed the carburetor for anything yet. Save that for last. A lot of people go right to the carburetor thinking that's a problem, and normally that thing's fine. The more they mess with it, the more it's out of adjustment, and the more they ignore that it's something like timing. Anything like that that's causing them problems. All right, so now hopefully you've gone through all the checks, and if things go your way, your car is running, driving, stopping, getting you A to B. Now there's still a million things that could go wrong, but there's a million chances to learn more and more about your car, how to fix your car, how to work on a great old car like this. And by the end of it, you'll know your personal car better than anyone else on earth. And that's the fun of it. That's when it really becomes yours. And when you go out, talk to people, you can go talk about all these things, all these little adventures or misadventures you had. Like, hey, this thing wouldn't go up a hill, the timing was wrong. Somebody set that wrong, I got it right. Pride in that. And I'm gonna keep working on this thing, keep making it better, and now that I can drive it around, enjoy it as much as I can. How could I forget? Tires. Tires. Old tires are homicidal balls of rubber plotting to kill you. Everything rubber in your car could kill you. That's why we talked about brake hoses, fuel lines, vacuum hoses. All of that needs to be changed. And these are the parts that touch the road. Change them if you don't know how old they are. Now they have a date code. If it's more than 10 years, probably not trustworthy. If you're seeing cracks, definitely not trustworthy. These are new radial tires from Diamondback Classic that look like old bias plies with white walls. They're a little bit of money. You don't need to spend this much. But get new ones.